Hi everyone, welcome to another video, and today we're going to be going through topics 2.4 and 2.5, which are weather and climate and natural vegetation. So the first topic we're going to be going through is weather, and what you need to know about weather is what is called a Stevenson screen. So what this is an instrument that contains weather instruments such as thermometers and hygrometers, which we'll go to in further detail later on in this video. But what you need to know is that this box here is used to store weather equipment, and it keeps a controlled environment for them to measure different weather elements such as the temperature or the humidity of the area. So what you need to know about the Stevenson screen are the characteristics it has to aid in collecting weather data. So what you need to know is that this roof here, so roof is double layered for insulation. And you also need to know that these slats here, so slats for air circulation. And you can tell it's made of wood, so made of wood to conduct heat. It's also painted white, so painted white to reflect sun's rays. And finally, it's raised on stilts to prevent ground radiated heat. Okay, so those are all the characteristics you need to know, and you should definitely know this really well because it's quite a common question that comes up if this option topic does come up in section B of the paper 1. Okay, so now I'm going to be looking at the placement of Stevenson screens and where they should be placed. So they should be placed away from buildings, and this is because so that they're not affected by the heat. The next is away from trees, and this is so that it's not sheltered and therefore can collect a more reliable data set. It should be on grass, as you can see in this photo here, so that the heat isn't absorbed by the ground. And it should also be away from the public. And this is so that it doesn't get tampered with or vandalized, so that the data collected is more reliable and accurate. Okay, so now we're going to be looking at the specific weather instruments. So the first is wind vane, and this measures wind direction. So what you need to know about wind vanes is how it works. So the broad end catches the wind, so this part here catches the wind, and this causes the arrow to spin around, and then the compass points are fixed on a tall pole, as you can see here, so it rotates on a pivot. And basically the arrow points in the direction the wind is coming from. Okay, so that there is how a wind vane works. Next, we're going to be looking at anemometer, which measures wind speed. And what you need to know about anemometers is that they're cups facing different directions. And then when wind blows, it causes the cups to rotate, so it'll go this way around as shown by the arrow. And it can either rotate clockwise or anti-clockwise depending on the wind direction. And depending on how fast the cups rotate, there will be a meter here. So this meter shows a reading for how fast the wind speed is. Okay, so that's all you need to know for anemometers. Next, we're going to be looking at a rain gauge. Basically what this is, it measures precipitation. So this precipitation can be in the form of rain, hail, sleet, or snow. So basically what happens is that a small depression is created in the surface, and a small jar is placed into the depression. And basically what happens is that a funnel here is placed on top as shown in the diagram. And basically over time water will be collected through the funnel here. So when precipitation happens, it will go through the funnel and into the jar. And after the set period of time in which the precipitation is being measured, it is transferred to a measuring cylinder to measure the precipitation. Okay, so that's all you need to know for a rain gauge. So next is a maximum minimum thermometer, and this can also be called a 6's thermometer. And what it does is it measures temperature. Sorry, this is supposed to say thermometer here. Okay, so anyways, what happens is that there will be a maximum temperature and a minimum temperature on either side of the U shape. So as you can see on this side here, this side measures minimum temperature, and the other side measures maximum temperature. And basically what happens is that you just read the readings from the minimum and maximum temperature. So so we will take these readings here, and what you do with those readings is that you add them together. So maximum temperature plus the minimum temperature, and you divide this by 2 to get the main daily temperature. So mean daily temperature. And of course this will be probably in degrees Celsius in most examples, but it could also be in degrees Fahrenheit. So just make sure you look at the units that are given on the 6's thermometer if you're ever given a diagram and asked to calculate the main daily temperature. Okay, so now we're going to be looking at wet dry bulb thermometers. So this measures water vapor content in air. and this is basically what humidity is, so you can just use humidity for simplicity. So the hygrometer contains mercury, which is represented by the red line as shown in the diagram. And basically what happens is that it rises and lowers depending on the humidity. And if there's less moisture in the air, the evaporation will increase in the dry bulb. So this will increase here if there's less humidity, and this will decrease as a result. So if less humid, dry bulb will increase, and the wet bulb will decrease. And this is happens vice versa. So if it's more humid, then the dry bulb will decrease and the wet bulb will increase. And basically that is basically how it works. But if both of these if both of them are at the same level, so if both bulbs give the same reading, humidity will be 100%. So just keep that in mind if you're ever asked to calculate the humidity. So just keep in mind that if they're both at the same, give the same reading, then you would write down that the humidity is 100%. Okay, so now we're going to be looking at a mercury barometer. And basically what this does is it measures air pressure. And basically how this works is that when the pressure increases, the mercury in the tube will rise. So just think of it as the pressure pushing it down. So there's more pressure pushing the mercury in the trough down, then the mercury will rise. So mercury rises when pressure increases, and therefore the rising will stop when the pressure inside and outside of the tube equalizes, and therefore a reading can be read here, for example, to measure the air pressure. So next we're going to be looking at a Campbell-Stokes sunshine recorder. And basically what this is, it measures length of sunlight in a given period of time. Okay, so what happens is that there's a glass sphere here, as you can see, and the sphere focuses the sunlight onto a recording card. So the recording card are these lines here, so the beige area here. And basically what happens is that the rays leave a burnt trace on the card, which indicates the amount of sunshine that is left on the card. So I'll summarize that on the side. So the sphere focuses light rays onto the recording card, and a trace is left on the card, which corresponds to the length of sunlight. Okay, so that is what a Campbell-Stokes sunshine recorder is. Next we'll be looking at an octagrid, and this measures cloud cover. And basically what happens is that you hold up the grid in the sky, and then you count the number of squares occupied. So usually for this, the grid will have 8 squares in them, but it could have more depending on multiple factors. So yeah. So now you need to know the benefits of using digital weather instruments. So they are greater accuracy because the data obtained has more decimal places, for example, and therefore it can increase the reliability of the results. And there's also instant processing and analysis by a computer. There is also less human error, and it's also easier to read, and also continuous data can be obtained. Okay, so those are the benefits of using digital weather instruments. And basically, now we're going to be looking at climate graphs. So basically what a climate graph shows is how weather characteristics such as the temperature and rainfall change over the course of a year. So this is an example from Malta, which is a island country in the Mediterranean. And it shows how the temperature increases and decreases over the year. So as you can see, the temperature increases until around 31, I would say. And then from January to July, and then it decreases back to 18 in December. And as you can see, the rainfall is also shown on this graph. So the bars represent the millimeters of rainfall in that month. So as you can see, it decreases as you go into summer, which is the June, July, August period, and then it increases back up as you approach December. So what you need to be careful of is that lines always represent temperature. So line graph represents temperature, and you also need to know that the bars represent rainfall. You also need to be aware of the axis that you're reading from. So this one measures temperature, and this one here measures precipitation. And you need to be really careful because these can easily be misused, and you can easily make mistakes by reading off the wrong axis. So for example, you might read this as maybe around 29, but in reality you're supposed to be reading on this side here, and this would be approximately like 78, for example. So it's really important that you look at the axis correctly and you're reading the graph properly so that you don't lose out on easy marks. Okay, so now we're going to be looking at the global distribution of climates and ecosystems. So as you can see, the desert climates lie on the tropics of Cancer, which is this, and the tropics of Capricorn, as you can see here. And as you can see, tropical ecosystems lie on the equator. So now we're going to be looking at the characteristics of different climates, and we're also going to be looking at the climate graphs of the different ecosystems and see how they differ from each other. So first, going to be looking at equatorial or tropical characteristics. So the climatic characteristics include near the equator. It also has high annual precipitation. It has a low diurnal range. It has high humidity. And it also has no seasons, so the weather remains constant all year round. And then now we're going to be looking at the ecosystem characteristics of tropical climates. So there's a high biodiversity and also a rapid nutrient cycle. And this is because of the high rainfall and temperatures, so therefore nutrients are rapidly cycled throughout the atmosphere, and the plants and all the organisms that live in these equatorial climates. And here's a radar graph, sorry, not a radar graph, a climate graph of a typical equatorial climate. So basically, as you can see, the temperature remains constant, and although the rainfall varies a little bit, it still remains pretty constant throughout the year as compared to desert ecosystems, which we'll look at next. So so now we're going to be looking at hot desert characteristics. So the characteristics of this is that it's near the tropics of Cancer and Capricorn, which I discussed above when we were looking at the global distribution of ecosystems. It also has a low annual precipitation and also has a high diurnal range, and it also has distinct summer and winter seasons, and also has low humidity. Okay, so now we're going to be looking at the ecosystem characteristics of desert climate. So it's quite literally the opposite of tropical ecosystem characteristics. So it has a low biodiversity and also has a low nutrient cycle. Okay, so here's a typical climate graph for desert ecosystems, and as you can see, the rainfall varies quite a lot. So in the winter months it tends to be quite high, but in the summer months desert ecosystems tend to get little to no rainfall at all. And you can also see the trend in the temperature. So as you approach the summer months, it will become quite hot, and then in the winter months, so within the first quarter and the last quarter of the year, the temperature drops. Okay, so now we're going to be looking at the factors that affect climate. So first going to be looking at latitude. So for latitude, solar radiation is concentrated at equator, but it is more dispersed at the poles, so the north and south poles, because there's more atmosphere that has to pass through, and therefore the latitude can therefore have an effect on the characteristics of ecosystems. Next is altitude, and as altitude increases, the temperature decreases, and therefore it influences climates and ecosystems. The next factor is distance from the sea. So inland areas heat up quickly in the summer, than coastal areas, and it also cools more quickly in the winter. So inland areas tend to have a greater diurnal range in temperature. So the next thing is ocean currents. So there may be warm or cold currents in oceans, and this can warm or cool the adjacent land. So this influences the climate. Okay, the next is wind. So wind coming from warmer areas will increase temperatures, and therefore this influences the ecosystems, as they're heavily reliant on the temperatures of the area they're found in. And finally, pressure systems. So low pressure systems have rising air, and because the air can rise, it can condense to form clouds, and therefore there's more precipitation. And in high pressure systems, the air sinks, so there is a lack of precipitation and more dryness. Okay, so now we're going to be looking at the causes of deforestation. So the first cause you need to know is industrialization. And this is because land needs to be cleared in order for development of industrial estates. So therefore, trees will need to be chopped down, which therefore causes deforestation. The next is urbanization. And similarly to deforestation, land needs to be cleared for housing and the development of commercial and financial centers, and also for retail and leisure purposes. The next cause is the building of roads. And again, land needs to be cleared to build the road so that it can connect different parts of the area. Next is hydroelectric power. And this is because land needs to be cleared in order to build dams, which are needed to generate hydroelectricity. So therefore, this will lead to more deforestation. And finally, population growth can also increase deforestation. And this is because there's more demand for food, and therefore more land is needed for agriculture so that crops can be cultivated and cattle and animals can be grazed. So these all cause deforestation. And now we're going to be looking at the impacts of deforestation. So I separated them into environmental, social, and economic impacts. So we're going to be going through them one by one. So one environmental impact is the increase in CO2 levels. And this is because there is a lack of vegetation or trees that are needed to for photosynthesis, which produce oxygen, and therefore carbon dioxide will remain in the air, and the air can become really toxic after a while. So the next environmental impact is that interception decreases, and this therefore causes surface runoff to increase, and this also causes the deprivation of nutrients in the soil, because when surface runoff increases as a result of precipitation, it will carry nutrients away from the soil, and therefore new vegetation won't be able to grow as well. The next is an increase in monoculture. And by this decreases the biodiversity of tropical ecosystems. And those are the environmental impacts that you need to know. Now we're going to be looking at social impacts. So the first social impact is less natural food available. And by this I mean food that grows in rainforests. This could be like bananas or orangutans. And therefore it can decrease the organic nutrients that us humans are consuming. The next is harm to indigenous communities. And this is because these communities may rely on trees for shelter, and they could also be very used to living in tropical conditions where there's high biodiversity and lots of trees. And if we remove that from them, then they might not be able to survive as well, and could therefore lead to the erosion of these communities. And therefore, the last one is an increase in landslides. And this is because there is less roots, because there's less vegetation, obviously. So less roots mean that the soil can't bind together, and therefore the soil will be more unstable. And this causes landslides. It can also cause the destruction of homes, businesses, and can also have socio-economic impacts on individuals and the societies that live that are affected by the landslides. And finally, we're going to be looking at the economic impacts. So one positive from this is that there is more jobs in mining, and this is because when land is cleared, there will be more mining, and therefore more people would be needed to extract raw material from the earth. And yeah, so the next is the increase in exports, and this is because there's more to exports. There's more timber, and because the land is cleared, more crops can be grown, and these can be sold, which generates incomes for farmers. And finally, another economic impact is that there is less eco-tourism, and this is because ecotourism is primarily based on the natural environment. So this may harm the tourism sector of the economy, and this can also lead to a decrease in employment in the tourism industry. Finally, we're going to be looking at the case studies you need for this topic. So the first is a case study of a tropical rainforest, and what you need to know are 3 causes of deforestation in that specific rainforest, 3 effects of deforestation, and also 3 solutions to deforestation in that forest. And you also need to know 3 adaptations of plants to survive in that forest, and 3 adaptations of animals, as well as 3 climatic characteristics that are found in those forests. The next case study you need to know is an example of a hot desert, and you similarly need to know 3 adaptations of plants to survive in those arid conditions, and 3 adaptations of animals to survive. You also need to know 3 climatic characteristics, and you also need to know 3 causes of why there is low rainfall in hot deserts. Okay, so anyways, that is the last video of theme 2, which is the natural environment. I hope you found those videos useful, and I'll see you in the next video. Bye.